All right, so welcome to the stream here this evening. It's about 8:30 here where I'm at night, and we're going to look tonight at writing formulas for chemical compounds here. And as we're doing this, I really want you to think about writing formulas and names as language, because what we're trying to do is communicate information about chemical compounds. We have rules, we have conventions, all these patterns, and it makes up kind of the language of chemistry. And what's kind of nice is that that language is universal. I can talk to anybody around the world, show them a chemical equation, and we agree, we know what's going on there. So for you as students, being really fluent in the language of writing formulas and names, that's going to make you a lot more effective, whether you're doing the NEAT, the MCAT, the SAT2, AP, any of these. You've got to get that language. You've got to be fluent so you can work quick. So let's do some problems here. Let me bring you over here. And the way to get really good at this is to practice. So the more that you're practicing this, the quicker and more fluent you become. So let's try one. We're going to start right out here with magnesium sulfide. So take a minute, see if you can write the formula for magnesium sulfide. Wow, it's 2:30 p.m. for somebody there. Big time difference. All right. So magnesium sulfide here. The way we do this, if you've been watching the last few streams, is first we've got to decide, is it ionic or covalent? So magnesium, that's right here. Sulfide, that's from sulfur. Metal and a nonmetal. So when you have a metal and a nonmetal, it's ionic. You've got to worry about these charges here. So all we really need to do is write Mg for magnesium and then S for sulfur. Then we look the charges up. Magnesium, all of these in group 2 are 2 plus, and then sulfur there with oxygen, 2 minus. Since the charge is balanced, we're good. That's the formula for magnesium sulfide. And as we go through and do this tonight, it's real helpful if you actually work these out on a piece of paper. It'll make that stick in your memory just so much better. All right, let's try another one. Let's clear this all off. So you give this one a try. I'll give you 30 seconds or so. Carbon tetrabromide. Carbon's right here and bromine right there. Give it a try. All right, I from Brazil. Nice. Henry's got it there already. Good job. So let's try it. So in this case, you should note that you have a prefix in front of bromide. So that already tells you it's going to be a covalent compound. You're going to have 2 nonmetals here. So when it's covalent, it's kind of nice. You don't have to worry about charge. All you got to do is write carbon and then bromine and tetra. Tetra means 4. There used to be a game called Tetris. I think the pieces looked like, how did they look? Like this. They had 4 pieces, and you'd try to drop them all so they'd all line up. Anyways, tetra means 4, so it's CBr4, just like Henry said. So we have ionic compounds, covalent compounds, and as language, they have different rules. All right, let's do another one. Let's go over here. And for this one, I'm going to put a poll in the chat. So try to solve this one here, and then I'll put this in the chat, and then you can go ahead and see if you choose the right answer. We'll see how everybody's doing here. And be careful, because carbonate, when you see ATE, it's not on the periodic table. It's a polyatomic ion. All right. There's the poll. So go do the poll. I'll bring it up and we'll see how many people are doing this right. Morning for a lot of folks. Wow. And Mukesh, you're right on about that one. Let me see if I can pull the poll up here. So we have 2 responses, and so far everybody's right. See if we can get the most responses I've ever had so far. It's only the 3rd poll I've done is 7. So I'm hoping tonight to get more than 7 responses. I've got someone from Canada. Excellent. I've never been to Canada. All right. Well, I'm going to move this over here, and some other folks maybe will be responding. I think it updates dynamically. I don't have to reload. Oop, I don't know what happened there. All right. So calcium carbonate. When you're looking at calcium carbonate, you know that, whoops. So you know that calcium, that's going to be a metal right here. Where's calcium? Right. Nope, that's cesium. Calcium Ca right here. But carbonate, when it ends in ATE, it's not on the periodic table. It's going to be a polyatomic ion. And in this case, it's the CO3 2-. So you're right. Calcium and then carbonate, CO3 2-. Calcium, we said, is 2+. So charges balance out. CaCO3. That's calcium carbonate. So those polyatomic ions, I really recommend you memorize these 6 right here because they come up all the time in chemistry. All right, now we got a hard one, aluminum sulfate. Let's see if you can do aluminum sulfate. So again, be careful, we have that ATE on the end, so it's not going to be on the periodic table for the sulfate. Give it a try. Mukesh, it's not Al2S3. That's aluminum sulfide. You want the sulfate, polyatomic ion. All right, let's try this one. So you write aluminum. Aluminum, that's right here. That's a metal, just with the metals over here. And sulfate, we want to look it up here. Where's it at? Right here. I think sulfate is the one you see the most often. SO4, 2-. And the 2-, it applies to the whole sulfate ion. So aluminum, we see here 3+. So I'll show you my favorite trick. It's called the crisscross method. You take the 2, you move it down here. The 3, you move it over here. Get rid of these charges. And then because we have, oops, get rid of that charge. Because we have 3 of these, we can't have 4 and 3 next to each other. We want to put parentheses because we have 3 of these. That's the formula for aluminum sulfate. And Angie got that there. Excellent. So let me do that again. I'm going to criss them and cross them again for you here, just because I like doing that so much. Take the 2, move it down here. The 3 over here, get rid of these. Put your parentheses in and bam, you got it. And if you check the charges, you'd have a 6+ here and a 6- here. Charges are all balanced. Sound good? I hope this is helping everyone here. Let's do copper 2 sulfate pentahydrate just to make things a little interesting. So let me get rid of this. This one you use in the lab a lot. This is a real common chemical because it's not too dangerous, but it does a lot of neat reactions. So I think I have some here. Yeah. See how we can do this. Grab a crystal of copper 2 sulfate pentahydrate. That's what it looks like. It's not super dangerous. It's very soluble, dissolves in water, and kind of neat blue color. So anyways, try to write the name for copper 2 sulfate pentahydrate. You should be able to do the first part. Second part's a little hard. Hey, we got 5 responses on our form and everybody got them all right. Sweet. I think some people either memorized copper 2 sulfate pentahydrate or just really smart, because I see 2 answers that I would agree with. All right, so whenever you see this Roman numeral here, they're trying to help you out because copper is a transition metal, so it can have a different charge. Oops, I'm not on screen here. Let me go over here. There we go. So copper is a transition metal, so it can have it's usually 1 plus or 2 plus, but here they tell you that it's 2 plus, so that helps. Cu 2 plus, and you remember the sulfate down here. Make sure you remember the sulfate, 2 minus. So for that part, we're good, right? Everything is all canceled out. We have net charge of 0. Let's keep these together. But that pentahydrate, the reason I show you this one is because it comes a lot up on labs, and sometimes the questions on exams for labs, they'll put this in here. So when you see penta, if you think back to like a pentagon or some of the prefixes down here, here's penta right here. Penta means 5, hydrate means water. And then they put this dot to show that there are 5 water molecules around each copper sulfate formula unit. So you get your copper 2 sulfate, then you have the pentahydrate. If you heat it way up, this will go away and you'll just have CuSO4. But then it's just a white powder. It's not as cool as the blue color. That's copper 2 sulfate pentahydrate. All right, let's do one that you'll probably end up seeing a lot in chemistry, and for some reason students, this just kind of messes them up. Let's put it up here. It's called oxygen gas. So when you see oxygen gas, sometimes it's called diatomic oxygen or molecular oxygen. It is just O2. So if it's diatomic, that's easy because it's 2 atoms of oxygen. If it's molecular, you need to have 2 atoms to have a molecule, or just oxygen gas is O2. You'll see H2 when it says hydrogen gas, N2 for nitrogen gas. What else do we have? Cl2, Br2, and I2. So whenever they say like iodine gas, they're talking about I2. You'll see that in chemical equations. I do some organic chemistry. I'm not as good at organic chemistry, but maybe we'll do a stream. What type of organic chemistry are folks interested? That would be my question. All right, so I'm going to move this over here. And so typically on a test, what'll happen is you'll be given something like this, an equation here, and asked to write everything out as a formula. And sometimes you're asked to even balance it at that point. So let's just kind of work through here. When I see something like this, I can actually put this right over here. When I see something like this, I see barium nitrate. That 8 tells me I have a polyatomic ion. So we have lots of polyatomic ions here. So barium nitrate. Here's barium, and the nitrate's NO3 minus. Another great one to remember. And you can do the crisscross method here as well. This is 1 plus. You could just move the 1 here and the 2 out here. Let's make that really look like a 2. That was a pretty weak 2. Put your parentheses around, get rid of your charges. So you could do barium nitrate like that. All right, thanks, Kimchi. I appreciate that. So that's barium nitrate. How about sodium sulfate? Let's put that in there. Sodium sulfate. Let's put our little AQ. It's dissolved. Nitrates are very soluble. You write sodium. You write sulfate, which you should know by now. 2 minus, 1 plus. And you can either, you know you're going to need 2 of these to balance that out. So there's your sodium sulfate. Anybody know what type of reaction this is, just looking at it? Double displacement. And then we end up with barium sulfate, Ba2 plus, SO4, 2 minus, so that's good. And these will all be aqueous. And then sodium nitrate, Na is positive. We put our nitrate in, that's negative. That's it. So that's how you end up doing that. So you'll see quite often they'll give you this, and then they'll ask you to balance it, which I think that's all you have to do. Yeah. All right. So let's go over and do 1 or 2 more. I don't think we'll get through a lot more, but I'm hoping you really get the idea here. How about you do this one here? Let's do magnesium hydroxide. I'd really like you to get that one correct. Magnesium hydroxide. Hydroxide's the one you want to watch out for. It ends in IDE, like the things on the periodic table, but it is a polyatomic ion. Kind of interesting. This is the most people I've had in a stream before, so that's kind of exciting for me. Okay. So let's do this. Magnesium right here, and then hydroxide we said is here. So it's ionic because you got a metal and a polyatomic ion. Mg, 2 plus. Yes, good job, Angie. Mg is 2 plus. Hydroxide is OH minus. It's important to stress that negative charge is on the whole thing. So it's 1 minus. And when we write charge, the plus or the minus comes after the number. Hey, Bayan. So you can christen and cross them like that, or you could just see that you need 2 of these to balance the 2 plus out. Put your parentheses in like that, or kind of like that. And that's magnesium hydroxide, MgOH2. No, this is not pre-recorded. I'm actually alive right now, for now. Okay, how about we do one with a poll here? So let's just kind of undo all this. I'm using a program called Inkscape to do this. It's an open source program called Inkscape, and I use that to write in. So it's pretty cool, especially since it doesn't cost anything. All right, I'm going to put a poll up. We had 5 people before. Let's see if we can beat my record of 7. That would make me really happy. So try to figure this one out, and then I'll put this here. There it is. Yeah, let's see if people can get this. Don't put it in the stream. Just put it in the form. I think that I have the wrong, I think I have the wrong thing here, even though everyone's getting it right. So the form is for magnesium hydroxide, not nitrogen pentoxide like I had. 6 responses, 7 responses. We're on the edge of breaking my record. One more person, bring us over. Almost there. All right, so we did magnesium hydroxide before, so you guys hopefully know that one. That's a good way to study if you see things several times. It really does lock it into your memory. Let's do this one. Well, 9 people, and they all got it right. Excellent. Good job. Yeah, the polls from the previous one, All right. So dinitrogen pentoxide. We'll do this and then one more, and then that's probably about all I got in me tonight. When you see di or pent, you know it's going to be covalent or molecular. So those are great because you don't even have to worry about charge. Nitrogen, oxide is oxygen, di is 2, like a pair of dice, pent is 5, like a pentagon. That's the formula. And when you look at the name here, note we don't put A before the O. We don't have two vowels here. We always just put like oxide. We wouldn't put two vowels together. All right. We're going to wrap up with nitrogen. No, what are we going to wrap up with? Let's wrap up with lead 2 bromide because it's good to do the transition metals. For some reason they cause students problems. So give this one a try. I'm actually not Canadian. I live in Washington, just outside Washington, D.C. here in the United States. So nope, not Canadian, but I have a great respect for the Canadians. All right, lead 2 bromide. This is a big key. If you see this, you're thinking transition metal. And usually we think of these as the transition metals. Lead and tin are called post-transition metals, so they act like the transition metals there. That's why we need the 2. So Pb, 2 plus, bromine, right here in group 17. These are all 1 minus when they form ions. Let's cross them. Boom, boom. And then we just get rid of the 1 because we don't really need to write that by convention. As we said, this is language, right? There are conventions, and we've just agreed not to write the 1. Okay, that's it. PbBr2. I think that's it. You know, when you think about studying and learning, what research has found is that if you study for longer than 20 minutes without a good break, your learning kind of drops off a cliff. So you always want to study really hard for 20 minutes, but then you do really need to take a break. So as I'm doing this here, my thinking as a learning scientist is that if I do my streams longer than 20 minutes, I'm probably not helping that much. So I'm going to end here. I did a video and I published it, I think yesterday, on using the Crisscross method, writing ionic compounds. You might try that out. There's a lot more practice there. And I think I have, let me see if I can find this for you here. A link to the application we played with the other night that I built for practicing. Yeah, here it is. Put that in there for you. If you want to practice all your naming, you can do this until you're just really tired of doing it, or really good. Excellent. Well, thank you, everyone. I appreciate it. I'm going to be back on Sunday, Tuesday, and Thursday. Those are the days I'm going to do this. And I'm going to think about going to Canada during that time. It's probably about, if I drove there, it would be probably like 14 hours or so, maybe more. But anyways, thank you, everyone. Good night.